This video is a short tutorial for the student-led example that you're supposed to do on your own. So please pause the video and try the student-led example on your own. Yes, the calculations are very similar to what we did for the two-tailed test, but it's good practice for you, and you also need to make a new decision. So here I've highlighted some of the important information. We have an N of 64. We have a population mean of 200. And we have a standard deviation of 48. And the teachers find that the students given the special instructions have a mean, so a sample mean, of 220. So now we want to calculate the significance for a one-tailed hypothesis test. So first what we need to do is state the hypothesis. So if we said that our sample mean was 200, we said our sample mean was 200. I like to start with the alternative hypothesis. And we're going to say that the mean of our treatment group is greater than 200, which means that our null hypothesis is going to say that the mean of our treatment group is less than or equal to 200. So we're saying that we predict that students that are given special instructions on the achievement test will have a mean greater than the population mean, but the null hypothesis states that their sample mean will be less than or equal to the original population mean. Next, we need to set the criteria for the decision. So again, we're going with an alpha of 0.05. So we need to come over here. We find that 0.495. We find our z is our critical. Z is going to be 1.65. And again, you can just know that by remembering, you can just remember that. You don't always have to look it up. Next, we need to calculate the significance for a one-tailed hypothesis test. So here is our formula. And first thing we need to do is calculate our standard error of the mean. So we take our standard deviation, which is 48. We put that over the square root of 64. That's going to give us 48 divided by 8, which is going to give us 6. Then we take that and we plug that into our z formula. We have a sample mean of 220 minus our population mean of 200. We take that and we put that over our standard error of the mean, which is 6. We got that from here. When we calculate that all out, we should get 3.33. So now we need to make our decision. So our critical z was 1.65. We got that calculation, or we got that from the unit normal table. Our calculated z is 3.33. So let's think about our diagram again. Go out here. 1.65 is that critical value. Now 3.33 is greater than 1.65, which means it's going to fall way out there. So that means we reject the null. And putting it into words that you would see here. Let me just erase this really quick so you can see it well. Is among high school juniors, special instructions for the student achievement test significantly affect test scores. And the z equals 3.33, p is less than 0.05. So again, you will need to know how you would write these things in the literature for the test.